Dear students, welcome to our very interesting class on concepts of evapotranspiration of basics 1. In the previous class, we just tried to understand what is evaporation, what is transpiration, what is the definition of evapotranspiration, then what are the factors affecting the evaporation, what are the factors affecting the transpiration. Now, so before we go into concepts of evapotranspiration, I just would like to inspire you with a very small quote. What is it? The secret to getting ahead. The secret to getting ahead is getting started itself. Is getting started itself. So unless you start working on your okay improving knowledge, you just cannot go ahead with others. Others will compete. So when we will be ahead of them, the secret to getting ahead of our friends is just getting started by yourself. Good. Now, so let's go to our the first slide of evapotranspiration. This I would like to demonstrate to you. This is a crop, a reference crop evapotranspiration. This is another. Okay. Now I explain to you what is the reference crop evapotranspiration. I told in the previous class, what is evaporation? Evaporation is a physical process in which the water is converted into vapor by taking, okay, 500 calories. In different books, different numbers are given. In some books, 460 calories. In some books, 630 calories. In some books, 540 calories. But of course, it is not to say that I have gone here, I have gone there. From the most renowned scientists who have worked on evapotranspiration, we finalized 500 calories for the areas between Tropic of Cancer and Tropic of Capricorn. Okay, so that's what we call it. In other words, for its own crop. Okay, right. Anyway, now reference crop evapotranspiration. I would like to explain to you the evapotranspiration. Okay, once again, I would like to say the combined loss of water both from the soil and plant is known as evapotranspiration. Now, see the evapotranspiration rate from a reference surface. What is the reference surface? Now, I will tell. This is the reference surface. Crop is the reference surface. Now I am holding the crop you are seeing. Now the evapotranspiration rate. Rate means, first 1 hour, second 1 hour, rate. Change with the time. Physics, general physics. Now, so the evapotranspiration rate from a reference surface, not short of water, is called a reference crop evapotranspiration. Now you see here. Now here, come good amount of water, good amount of water. Once again, I would like to say the evapotranspiration rate. What is meant by rate? For every day, for every 1 hour, for every day, for every week, like that. Now, so the evapotranspiration rate from a reference surface. This is the reference surface. The crop canopy is the reference surface. What is meant by canopy? The crop itself is the canopy. Okay, right? So, not short of water. Okay, we are giving excellent amount of water is called reference crop evapotranspiration. Why I am telling this one is that several times, please note that in different books, different technology are there. Once again, I would like to tell you, it is my fortune that I worked with the best scientists who have worked on the evapotranspiration. Okay, so we have. Okay, yes, I'm also a part of it. I'm very happy, not proud. Okay, I'm not jealous of any other scientist, but I also involved with them. We named it a reference crop evapotranspiration. Okay, right. We call it as the ET0, ETO. We call it as sometimes some scientists from Dr. Murthy, you are from India. Zero is invented by Indians. So that's why no, don't say ETO, you call it. Sir, I accept it. Not just for farmers. It is after thorough discussions of several months, years of work. Now, so the evapotranspiration rate from a reference surface not short of what is called as the reference crop evapotranspiration or reference evapotranspiration, and it is denoted as ETO. ETO. Right. I don't want to name the scientist. It may be biased. Okay, they are the experts. Of course, it is. I'm fortunate to be in that now. The reference surface is a hypothetical grass reference. Okay, this is what we found. Back body is hypothetical body like that. We also tried. Okay, to use this term. reference surface is a hypothetical grass reference crop with specific characteristics. Just for example, alfalfa, a wonderful crop, alfalfa. Okay, right. Now, for of course, I discussed why cannot our paddy, why cannot our horizon sativa, I told. No. So, because of some physiological characters, some scientists from crop physiology were there, plant physiology were there. So, we finalized alfalfa. Okay, for modern evapotranspiration purposes. Now, the use of other denominations such as potentially it is strongly discouraged. This is why I'm telling you, some scientists, of course, I'm not saying I'm not involved into their area for as far as agricultural crops are concerned. Please always reference evapotranspiration, ETO, not other terms. This is what I would like to say from the third line of this slide. Now let us go to the concept of reference. Evapotranspiration was introduced to study the evaporative demand of the atmosphere independently of crop development and management practices. What is meant by crop type? Different crop types are there. Okay, crop development, vegetative phase, reproductive phase, maturity phase, and management practices. Limited water is there, drought conditions. Unlimited water is there, under the wet conditions. We have supplemental irrigation, everything. So the concept of reference, evapotranspiration. This is the reference. Unlimited water supply. When unlimited water supply is there, crop is in its active growing stage. The combined loss of water, both from the soil and from the crop, is known as reference evapotranspiration. ET. Soil factors do not affect ET. Soil factors do not affect the ET. What are the soil factors we discussed in the okay? Uh, uh, Two classes. That's why I request you to subscribe to my YouTube channel, Agronomy Farmers Rural Development. Fundamentals we discussed it. The only factors affecting the ETO are climatic factors. Climatic factors I told several times. Just for your academic. Once again, I would like to say temperature of the water, humidity, wind speed, the pressure. Humidity and pressure are inversely proportional to evapotranspiration. Whereas temperature, or solar radiation, some books, standard books. Okay, I don't want to name the scientist name. So again to avoid the biasness, in some crops, some books you will find the solar radiation. Of course, we unbiasedly thought, okay, let us go for the temperature. Now, because it refers to the energy component. Now the next one is the humidity. Okay, humidity. Okay, and pressure are inversely proportional, whereas the temperature and wind are directly proportional to the evapotranspiration. Now, so consequently, what we found, ETO is a climatic factor and can be computed from weather data. So, weather is defined as a state or condition of the atmosphere at a particular place at a given state of time. So, evapotranspiration takes place like that only. So, it is from the weather point. Now, so ETO expresses the evaporative power of the atmosphere at a specific location. That's why take the definition of weather at a particular point of time, location. Okay, right. Particular point of time. Okay, at a particular location. That's why. So of the year and does not consider the crop characters and the soil factors. Now, of course, different penman, modified penman. This we discussed. Closely approximates grass ETO at a location evaluated is physically based and explicitly incorporates both. That's what I do, physiological and aerodynamic parameters. Crop physiologists were there, crop physicists were there, agrometeorologists were there. So once again, the method of ETO has all these things. Now let us go to crop evapotranspiration under standard conditions. After 1 minute, we go to non-standard conditions. Standard conditions of crop evapotranspiration under the standard conditions. What is it? The crop evapotranspiration under standard conditions denoted as ETC crop. See, ETO, earlier one, ETC crop. Now, once again, crop evapotranspiration under the standard conditions denoted as ETC is the evapotranspiration from disease-free, well fertilized. So, this crop is a disease affected. Disease affected. Okay, this crop is not disease affected. Here, this is not affected. This is affected. Now, the crop evapotranspiration under standard conditions means It is denoted as ETC. C is the crop. The ETC is the evapotranspiration from disease free. This is the disease free. Disease affected. Now, disease free, well fertilized crop grown in large fields, maybe like this, grown in large fields, okay, major area under optimum soil water conditions and achieving full production under the given climatic condition. You may put it, you may question it. Not given weather conditions, no, it's not weather because certain horticulture crops are there. They are more than 20, 25, 30, 40 years old. For example, mango, for example, coconut. So that's why we put this word given climatic conditions. So the differences in leaf anatomy, for example, you go for anatomy of the leaf, the differences in leaf anatomy, tomatal characteristics, that's what I thought. The upper surface of the leaf have got less stomata as compared to the lower part. That's why under the hot weather conditions, the leaves of certain plants, turn or tilted upward. Bottom goes up. So aerodynamic properties, that's what I would like to say. Next class, sir, I will tell aerodynamic properties and even albedo. What is the albedo? The ratio between the reflected to the incident radiation cause the evapotranspiration to differ from the reference crop evapotranspiration under the same climatic conditions. So, a crop, what is the standard conditions crop evapotranspiration? What is the crop evapotranspiration under the standard conditions? Means disease free. Number one, disease free. Unlimited water supply. Okay. Leaf anatomy, stomatal characters, aerodynamic properties, and even albedo. Okay, everything is under optimum conditions because we are giving optimum conditions by giving enough amount of water for both evaporation transpiration. This is what we call it as the under the standard conditions crop evapotranspiration. Okay. Now variations in the crop characteristics throughout its growing season. Kc for a given crop changes. Kc means crop coefficient. Crop coefficient. It is just like this, like this, like this, like this, like this, like this. This I will tell you the next class. Crop coefficient. Up to that point, just remember. Now, let's go to crop evapotranspiration. Non-standard condition. No, no need to say. Still, I am telling you for a non-standard conditions. Non-standard conditions is now, what is non-standard condition? The crop evapotranspiration under non-standard conditions, ETC, was what we named adjusted, ADJ. ETC adjusted is the evapotranspiration from the crop grown under management and environment conditions that differ from the standard conditions. What are the standard conditions? Several times I told. Unlimited water supply, crop is in its active growing state. Wonderful. Okay, completely covered. Uh, Leaf area is at its maximum. All those conditions. Now, so when cultivating crops in the fields, the real crop evapotranspiration may deviate from ETC. ETC means evapotranspiration of the crop. Okay, due to non-optimal conditions such as presence of pests, stresses, biotic, abiotic stresses, soil salinity, low soil fertility, water storage, or water logging. Now, just to avoid any confusion, non-standard conditions means standard conditions crop evapotranspiration is very easy. Non-standard conditions means crop is in its the crop is affected with some stresses, biotic, abiotic, all these things. So this may result in scanty plant growth, not like a healthy one like this. Not like a, okay, okay, not healthy like this. Not healthy like this. Is like this. Plant growth, low plant density, and may reduce evapotranspiration rate. The evapotranspiration of non-standard conditions is okay calculated by using a water stress coefficient Ks and by adjusting Kc, okay, for all kinds of other stresses and environmental constraints on crop evapotranspiration. This is ETC. First ETO, ETC, ETC adjusted. What are these? What are these? Simple, very interesting diagrams are there. ETO, climatic factors, that is the radiation, temperature, wind speed, humidity, plus grass reference crop is equal to ETO. Now, what is ETC? ETO, up first line. So, Kc factor, crop coefficient factor, we consider the ETC. Now, What is ETC adjusted? Simple. You add one more KS here. So ETO into KS into KC adjusted is called ETC adjusted. Now, I would like to tell you, evaporation can be measured. Transpiration can be measured. Different methods are there. Okay. But we are going to discuss in the advanced class. Up to that time, please note that Dastane and Sharma, they have devised an excellent tool. Okay. What is that? In the sunken screen evaporator as compared to open pan evaporator in the observatories. Okay. Standard observatories. Dastane and Sharma. IR. Okay. They have developed wonderful sunken screen evaporator. So almost crop coefficient values are very, very narrow. Narrow means, the combined loss of water both on the soil and the plant, okay, crop, okay, is almost equal to the water you can give it. That's what we would like to say. Now, just once again, I would like to press upon you. ETO is equal to the factors of the climate, not weather. It is because crop, crop is not just 90 days like a black gram, okay, green gram, maybe even 65 to 70 days. Paddy, maybe 120 or say 140 or say 170 days. Okay. But horticulture crops are there. So they are the plantations, just to give economic yield itself, they take 5 years. Active economic yield, okay, wonderful. Though they may take 20, that's why climatic factors we mentioned here, climate plus grass reference crop. Okay, alfalfa. ETO, that's what. So ETO into crop coefficient factor. Once again, the crop coefficient is like this, like this. During the vegetative stage, during the reproductive stage, during the maturity stage. This we will discuss in the next class. ETO into KS into KC adjusted is called ETC adjusted. So this is what I would like to discuss with you in the concept before we go to different Penman method, Monteith method, Penman and Monteith method, which I used during my MS in P3 and the Bowen's ratio. Okay, Papadakis method, different methods are there. Of course, we just go on advancing classes. We learn all these things. I assure you that we discuss all these things. May God bless you. All the very best. Okay. So once again, a quote. Okay. The secret to getting ahead is getting started. So with this, okay, I end the class. May God bless you. Thank you very much. May God bless you.